Good day to all. Today we are going to see about the topic of step counter method and mapping method. Previously we have seen about that cascade method. Likewise here we will see the step counter and mapping method. First we will see the step counter method. See the methods of that step counter methods are denoted here. First one is draw the cylinder and see DCVs. DCV means direction control valve, and draw the step counter modules for each operation according to the sequence from the left to right. Labels each module. Connect input 3 to the respective port of the DCVs, directional control valves. See this the T port. This is first one, this is second one, this is 3, this is 4, this is 5, this is 6. So here the example is given. For A plus module, port 3 is connected to left hand side of direction control valve cylinder A. And again the connection of input to previous module of port 6, and the connection of input 1 to previous module port 5. See what they are saying here, connection of 4 to this 4 to connected with the previous module of port 6, and this connect input 1 to previous module of 5. This should connected previous module of 5, and this 4 is connected with the previous model of 6. This one is 4, and connect input 2 to the input switches and the roller switches. This will be connected with the roller switches or normal input switches. We'll see one by one in that next. See step counter circuit with 2 cylinders. Here is a one cylinder here and another one is a cylinder here. The walls are here and the numbers of the walls is here it is 1 and here it's 2, here 2, 3, 4, 5. Here also this 4 and 5, and this one is a piston of end connection. This is only initial connection. Here it is 2 and 3 is there. Similarly, this wall will also having a same setup, and here also the same setup. See here it is A plus and A minus, here A plus, B minus and A minus. This A plus have a receiving from the 2. Then this will move up into that fourth part of that cylinder end. This cylinder L will have a connection here. See, you can see here, and this the cylinder up will have connection here. If you are giving the connection to here it is 2, then it will push up to that particular piston. If you are giving the connection to here, then this is the dead end. Likewise, we will give connection to all 4 sections, A plus, B minus, A minus. What we have given in that problem, see, you can see, connect the input 4 to the previous model of 6. 4 to previous model of 6. So if you are seeing here, where is the connection 4? Here it is a 4. It is connected with the previous section of 6. If you are see here, the previous section will come here. Likewise, the all section we will do. What is the next step? Connect the input 1 to the previous model of 5. Here it's 1 is there and the 5 is there. We will see, connect the input 1 to model port 5. So we have to connect the 1 to previous model of 5. Here it's a previous model of 5. You can see this is the step counter of circuit with the 2 cylinder. Now we will go to see the 3 cylinders. See here it is a 3 cylinder. Cylinder 1, cylinder 2 and cylinder 3. Likewise, we will give the connection according to what we have get it from that particular problem. Here it is common to all. This is the main connection 1 and 2, and here also 1 and 2, here also 1 and 2, here also 1 and 2, and see here, if you are seeing the up direction and also down direction, the connection will move up to that particular cylinder, then that will be the up, and if it is down means that will have a down connection. Now again we will see, connect the input 2 to the input switch or roller switch. We have to consider these 3 connections to that respective direct control valve. Connection 4 to 6, 1 to previous 5 and 2 to switches or roller switches. So we have to give connection to according to this 4 to 6 and 1 to previous 5, and the final one we have to give the 2 to roller switch or normal switches. So you can see here this 2 will connected with the switches everywhere. This cylinder also connect with the switches too. You see here this 2, here is also 2, here is also 2, here it is also, this 2 mainly connected with the switches. If the switches is on, according to that particular action will takes place. Here it is a 4th one. If you are giving the input to this 2, then the piston from that A1 position will move up to A0 position. See here, you can see this is the A0 position, A1 position, this is the A0 position. If you are giving from this 2, here it is in up direction, then if the piston is supposed to be here, if it is the piston supposed to be here, then this connection will move up this piston from A1 to A0. Then the output of that A0 will come to 4, then it will reaches 3. This 3, where we will have a connection with this 3, you will see this connection with the others. Likewise, all the connections should be made. Here it's for A. Here it's for A cylinder. Here it's for B cylinder. Here it's C cylinder. A0 is here. A1 is here. B0 is here, B1 here, C0 is here, C1 here. So according to that problem, we will draw the step counter method. Then the mapping method, it's the main difference between the stepping method and mapping method. We have to give the mapping like here. See what we have get it from the problem. A plus B plus B minus and A minus. This is the given problem. So we have to draw a Carnap map like this, and here we'll put A, here we'll put B. 0 and 1 connection, 0 and 1 connection. 0 is mean off, 1 is on. So according to that we will draw this mapping. If it is A plus means we have to rise from 0 to 1 because it is A plus. Then what will be the connection? It's again B plus. So step 2 is coming from B plus. And the third one is B minus. So the position is in on to off. So it will degrade B minus. Then what is that? A plus. So again it will degrade from here. This is the mapping method first step. We have to draw this Carnap map. Then we will go for this method again. These are all the things about the step counter method and mapping method. Thank you all.